In this video, we'll have a look at using the two-class presence-absence sampling plane. Let's say we are interested in Salmonella in a food lot. Because we are concerned about very low levels of contamination, we use an enrichment test to detect the presence of Salmonella, and consequently, we use the calculator in the two-class presence-absence number 1 tab. The calculator in the two-class presence-absence number 2 tab is very much equivalent to the one we're having a look at now, except that you can also specify the analytical unit amount as part of the calculation. There are several areas in this calculator, and cells which allow user input are as usually shaded in orange. We have an area at the top for specifying the sampling plane, and the corresponding OC curve is shown at the bottom. There is also an area for a point of interest, which allows you to calculate the sampling plane's probability of acceptance and rejection for any detection probability that you might be interested in. For example, consider this sampling plane with sample size n equals 5 and acceptance number c equals 0. If we are interested in a detection probability of, let's say, 2%, which is an estimate of the prevalence of contamination in the lot, then we would accept more than 90% of such lots. The corresponding point is also shown on the OC curve down here. The third area is an area for specifying the consumer and producer's risk points. For example, let's assume that at a detection probability of 5%, we can accept lots at most 10% of the time. We can enter these values into consumer risk point, and this point is now shown also on the OC curve. In addition, the actual probability of acceptance, which is 77.4%, is also shown. It is shown here in red because this probability is greater than the 10% that we have specified. Now, to find a sampling plan that satisfies the consumer risk point, we need to change the sampling plan until the OC curve drops below this point. Now, an appropriate sample size is essentially found by trial and error. So we might increase it to 10, 15, 20, let's go to 30, 40, 45, and at 45 the actual probability now turns green as it's dropped just below the 10%.